Well, good morning or good afternoon, once again. I feel like this is getting a little repetitive sometimes, but uh, I, I do love I do love being annoying, I guess is really what it boils down to. I love being annoying. So anyway, sorry if I say the same crap every time I start the video. It does feel repetitive and annoying. So anyway, today we're going to be talking about the definition of a horizontal asymptote. So that means this week we've covered vertical asymptotes, holes, and now horizontal asymptotes. And if you look on Thursday's and Friday's page, there's an overview, kind of notes of the details of all three. So I kind of take this in today's lesson and just break it down into kind of a quick step-by-step directions. Be useful on the quiz or a test. All right, so today we're talking about horizontal asymptotes, and we get this line y equals b called the horizontal asymptote. We can have three different possibilities, and each one's kind of different on their own, but nothing surprising. All right, so in this first one here on the left, what we can see is that x approaching infinity. So essentially we're approaching the horizontal asymptote on the right-hand side of the graph. The left-hand side of the graph, it's not approaching, it's kind of going away from it. But the right-hand side, it's approaching. So we would say as x approaches infinity, the limit of our function approaches that line y equals b, or that height b, whatever number that happens to be. So again, it's approaching it to the right. All right. Now, it could be also approaching it from the left as well, but again, it's important to notice it's probably, most of the time only going to be approaching it on one side, not both. All right. The second picture here, you can see that in this one, it's just approaching it from the top. That's all that's different. Everything else is the same. It can approach from either side. So that, again, shouldn't be surprising. But the one thing that is maybe a little surprising is this one here. You can see this one right here actually crosses the horizontal asymptote. Now, with vertical asymptotes, that cannot happen. Never happens. Right? But with a horizontal asymptote, it can, and it's the only thing that separates the two in the way that they work. So there's the little paragraph at the bottom talks about that you can have several vertical asymptotes, but only one horizontal asymptote. And again, a graph can never intercept a vertical asymptote, but it may cross a horizontal one. All right, so again, a couple of different small differences between them, but for the most part, they work kind of the same way. All right, now let's talk about how to find them. All right, so here's this theorem on how to find a horizontal asymptote. And again, it's a lot simpler than it looks, and that's just because the equation that they use to describe the generic rational function is really ugly. What that really means is that we can have many, many, many terms, but essentially we only need to focus here. Everything that happens after those leading terms doesn't matter. All right? If it's in standard form. That's the key. Got to be in standard form, starting with the largest exponent. So if it is in standard form, and we're starting with the largest exponent, and we have three possibilities for asymptotes. All right? So in reference, in these n's and m's that you're seeing over here, they are saying that the degree of the numerator is n. Thank goodness they made sense with that one, numerator and n. With the degree of the denominator is d. Oh, wait, no, not d. That would have made total sense. It's m. I don't know why. It doesn't make any sense. It should have been d. But anyway, it's m. Mathematicians are just weird, I guess. All right, so we have three possibilities as to what's going to happen here. All right, each one's kind of simple on its own. So first off, if n is less than m, so what the heck would that look like? Well, that would look like one where the numerator exponent, like 4x squared, is smaller than the denominator exponent, like 3x to the fifth. That's what it means by n less than m. The numerator has a smaller degree than the denominator. If that happens, then we get this y equals 0, or the x-axis is our horizontal asymptote. No real work to calculate it. It's just, that's what it is. Don't have to do anything. The 4 and the 3, they didn't mean anything there. All right, so now let's look at number 2. What if n equals m, meaning that the exponent on the numerator is, oops, I don't want to use another 3, or another 4, is the same as the exponent in the denominator. They match. The leading one. Again, all we care about is this leading coefficients and leading terms, not the other ones. So if they happen to be equal, then our horizontal asymptote happens at a over b. Okay, I see back in the function where that messy circle is. that A is just the coefficient from the numerator, and B is the coefficient from the denominator. That's where the horizontal asymptote would be. And if you're wondering where that would be on a graph, if we were graphing something and there's 1 and there's 2, 4/3 would be 1/3 of the way between 1 and 2. Horizontal asymptote would be there. All right, last option. 3, what if n is greater than m, meaning that the numerator has a larger denominator, or not larger power than the denominator? If that happens, then there is no horizontal asymptote. None. So again, the work's pretty simple. You don't have to do a whole lot with these. It's just deciphering which one to use and where to get the numbers from. That's the hard part. So let's try an example of all three types. All right, so the first one here, A, we want to see if there's a horizontal asymptote. So what I see in this one is that the denominator has a larger power than the numerator. See, the denominator has a power of 2, numerator a power of 1. Well, I go back, if the numerator is less, that's one of these. Numerator less than the denominator. So what do? If that's a number 1. If the numerator is less than the denominator, then we get the x-axis, or y equals 0. So we're done. Y equals 0. There's our answer for part A. Right, in part B, we can see that these have matching exponents for that first term. So let's go back and look. That's number 2 there. N equals m. That means we get the line y equals a over b. So that means I get y equals 4 over 2, the two leading coefficients. And of course, we always reduce. So our final answer on that one will be y equals 2. If you don't reduce, you will definitely lose points. This is not 3rd grade anymore. You're in high school. You're expected to reduce all fractions 100% of the time. All right, last one. We see these exponents here, and this would be one where the numerator has a greater exponent than the denominator. If we go back over here, that's that 3rd line, and that means that we have no horizontal asymptotes. There are none. All right, that's it for today. This is what you are doing, is finding which one of these 3 options you have. All right, it's all based on the degree of the numerator versus the degree of the denominator. Again, there is a little cheat sheet as well on today's page and on Friday's page, kind of just breaking all of these 3 things, vertical asymptotes, holes, and horizontal asymptotes, down into kind of one little quick location to find things. Again, that should hopefully help you on your quiz on Friday. All right, good luck today.